All right, here we go. Today, we're going to build functions from functions. We're going to create functions out of functions. Okay? So, how do we do that? Well, we're going to combine them algebraically, and we're going to do compositions of functions. And then on Wednesday, we'll look at relations and implicitly defined functions. And why would we do that? Well, for most of the functions that you'll encounter in calculus in real life, it can be combined. They can be combined or modified from other functions. All right. So if we have two functions, we can find the sum of the functions. F plus g of x comes from f of x plus g of x. Difference, f minus g of x. Product, we multiply them. Quotient, we divide them, provided that the denominator is not equal to 0. Okay? That's the biggest thing. You got to make sure that the denominator doesn't equal 0. So, now, let's look at the formula for f plus g of x of these two. F of x is x cubed. G of x is the square root of x plus 1. And that's it. That's all you do. Easy peasy lemon squeezy. F minus g of x is x cubed minus the square root of x plus 1. F times g of x is x cubed times the square root of x plus 1. And f over g of x is x cubed over the square root of x plus 1. Provided that x does not equal what? No, x can be 0 there. It cannot equal -1. It cannot equal -1 because what does -1 do? Makes the denominator 0. So, all right. So you'll have a couple problems that look like that. Should be fairly easy for you to do. Okay. Now, what function can we, if we take a function, add them up, wait, that's what we did. Okay, sorry. Okay, compositions of functions. Okay, f of g of x means we put the g function into the f function. F of g of x means whatever the g function is, we put in for the f function, and we replace the x of the f of x with whatever the g function is. Okay, you replace the x of the g of x or f of x with the g of x. Okay, so instead of going here and then here, f of g of x makes the whole trip all in one. Okay, so let's look f of g of x of this one. F of g of x. So the g of x replaces the x of the f of x. So it's 2 to the square root of x plus 1 power. Okay? Now they might say, well, what's the domain of this? Well, what does x have to be here to work? It can be -1, but can be any lower than that? No. So it goes from -1 to infinity. You have to have at least -1, but you can go to infinity. Okay? How about g of f of x? Okay? So you put the f of x function into g of x. So it's the square root of 2 to the x plus 1. Now, to find this domain, okay, what would this domain be? Okay? Is there any way to make this into a negative number? No. Any exponent on that, what if you might say, well, what if we have 2 to the -2 power? Doesn't that make it negative? No. 2 to the -2 power is 1 over 2 squared, which is 1/4. So that would be the square root of 1/4 plus 1. So there's nothing that would make this negative. So No. It's negative infinity to infinity. You can use any number in there. You can even use 0 in there, because what's 2 to the 0? 1. 2 to the 0 is 1. Anything to the 0 power is 1. 1 plus 1 is 2, square root of 2. Okay? So, all right. So that's composition of functions. Let's decompose a function here. Okay? So, if h of x is this, what could a g of f of x be for that? Well, that's what g of f of x is. So what would g of x be? What would f of x be? Okay? Well, g of x could be, if you're putting f of x into g of x could be just the straight square root of x. So then what would f of x have to be in this case if g of x was just a straight square root of x? X squared plus 5. Exactly. Okay. Let's do a different one where we're plugging it in. Let's say we have f of x. Let's say f of x happened to be the square root of x plus 5. What would g of x have to be to make this? It'd have to be x squared. Okay? So now you're kind of thinking backwards a little bit. You got to be able to think forwards and backwards with this. Okay? What would make that? What would make that? Well, we have two different things that would make that. Okay? So that's I think there's only, 8 problems on your assignment or so. I think that's what kind of the 8 problems cover is compositions of functions, adding, subtracting functions. The biggest problem is if you're asked the domain, find the domain. Okay? So let us get out of here. I got to push the escape button, I bet. Escape, quit, discard. All right, so we're good there. I'll stop